Okay. Good day, everybody. My name is Hadiza, and today I'll be talking about caching, what it is and how it works. So here's an analogy. Let's say you're a librarian and your job is to respond to students whenever they come to the library to request for books that they need to do their assignments, to make research and whatnot. The library is a very big place. So the process of going to search for these books, bringing it down to the students and returning it back to its rightful place can be exhausting, tiring, and time consuming. So as the students borrow books, you notice that there are some frequently requested books. There are some books that these students request for frequently. So you decided to bring this book down to your desk and put it in a shelf for easy access. So whenever the students request for these books, you can you have easy access to it and you can respond to them in no time. So that's great. This is not different from what happens in the web space. This is not different from what happens in the computing world. So we have frequently requested data, and this frequently requested data has increased over the years. So our normal database are slow and cannot keep up with these requests. And as humans, we have little or no patience. When we request for data, we want it delivered to us in no time, like ASAP. So how can we deliver this data with minimal delay? That is where caching comes in. Fast data retrieval is a necessity. It is not an option. It is very, very necessary. So that is where caching comes in. So caching data, it is a process that stores multiple copies of data or files in a temporary storage location or cache so they can be easily accessed later. Like I said, we have frequently requested data. So caching is just the process of storing this data, this frequently requested data. Once they are requested for, they are stored in the cache. So whenever requests for this same data are made in the future, it is saved quickly. It is saved fast. There is no delay in saving that data. So caching is using the computer's main memory to efficiently manage frequently used data. So we have a cache is a high-speed data storage layer which stores a subset of data temporarily. So in this case, in the case of the library example that I made, we have the fast retrieval bookshelf. So in the case of caching, what is this fast retrieval bookshelf? It is known as the cache layer. The cache layer is simply a storage location where you can store data and can easily retrieve it in future when it is needed. So a cache is a high-speed data storage layer which stores a subset of data temporarily. So the data is retrieved faster when requested for in future. And this isn't possible by accessing the data's primary storage location. So caching allows you to efficiently reuse previously retrieved or computed data. So when, like I said, when data is requested for, this data is then stored in the cache. So in future, whenever this data is requested for and when this data needs to be used, it can be reused efficiently. And in the diagram you have on the screen now, we have like two instances. The first one is request made without cache and the other one is with cache. So in the first instance, there we have three requests, and these requests are made from the user to the app, and from the app directly to the primary storage location. This can result in this can affect the user experience and can also result in high latencies. In the second instance, we have three requests. The first request was made directly to the data primary to the primary storage location of the data. Then subsequent requests, request 2 and request 3, were made to the cache. As we can see, that is going to affect the user experience in a very good way. It's going to improve the user experience, and also it is going to result in very, very low latency. Hence, fast retrieval data is implemented here. in the second instance. So I hope from now we can see how important caching is. So a cache primary purpose, the primary purpose of caching is to increase data retrieval performance by reducing the need to access the underlying slower storage layer. If it was not for caching, whenever data is requested for, these data are going to have to, the request is going to have to be made directly to the primary storage location, to the databases directly. And this can result in slower response, in slower retrieval performance, resulting in high latency. So caching layer is used to store data so they can be retrieved, so they can be served quickly. Retrieving data from the caching layer is way faster than getting them from the main source. So data is growing complex. Standard data stores are slow. Web application has to deal with millions of users. Data inputs has been increasing exponentially. Delays cannot be tolerated at all. So caching to the rescue. Caching can help us improve all of this and help us solve all of these problems. So one way to implement caching is by using in-memory stores. In-memory stores is just referring to the RAM. That's the random access memory of the computer. So one way to implement caching is using in-memory data stores. An in-memory database store stores data in a computer's main memory instead of a disk drive to produce quicker response. In-memory data stores all its data in the random access memory of a computer. So one way to implement caching is by using in-memory stores, and this stores all the data in the random access memory of a computer. And RAM has high request rates, or IOPS, that is input output operations per second. Therefore, caching results in improved data retrieval performance and reduces costs at scale. So RAM is used because of its high request rates, and this high request rates result in improved data retrieval performance and also reduces cost at scale. Because if we're to use database instances in this case instead of RAM, these instances, they have to be supported by resources, and these resources are going to come at different costs. So that is why we said this improves data performance and also reduces cost at scale. So, and this can also result in a great user experience. So, moving on, we have different benefits of caching. Caching improves application performance. So since access to data is significantly faster, this improves the overall performance of the application. So once you have fast data retrieval, it results in the overall performance of your it improves the overall performance of your application. So it also reduces database costs. Like I said earlier, a single cache instance can provide hundreds of thousands of IOPS and potentially replacing a number of database instances, thus driving the total cost down. Like I said earlier, a single cache instance can provide hundreds of thousands of inputs, outputs per operations per second. And this has replaced a number of database instances that, if they were to be used, are going to come at different costs. And so caching can help cut these costs down. So reduce the load on the back end. Caching can reduce the load on your database and protect it from slower performance under load, or even from crashing at times of spikes. For example, we have e-commerce websites, they run sales and like Black Friday and the likes. During these times, they have these times are times of spike, and if without caching, the load on the back end is going to be very much, and this can crash the system. this can crash the system. But with caching can help reduce the load on the database and protect it from slower performance at these times. And predictable performance. With caching, your application has a predictable performance, because by utilizing a high throughput in memory cache, this issue might be mitigated. For example, the time of spike that I spoke about. When we're in times of spike, the load on your application is going to be much, and this can result in high latencies and can make your application, the performance of your application, unpredictable. It might crash, it might be slow, but with caching, the performance of your application is predictable. And lastly, caching increase read throughputs. So in caching, we have different use cases for caching. We have the database caching. The performance, both in speed and throughputs, that your database provides can be the most powerful factor of your application's overall performance. Database caching allows you to dramatically increase throughputs and lower the data retrieval latency associated with back-end databases. And this results in improved overall performance of your application. So database caching can help you increase the increase throughput and also lower data retrieval latency. And as a result, this improves the overall performance of your application. Next, we have content delivery network caching. That is CDN caching. A CDN will reduce the load on an application origin and improve the experience of the customer by delivering a local copy of the content from a nearby cache edge or point of presence. So the edge of a network is geographically close to the device, unlike origin servers. So CDN helps deliver your content to your customers in no time from the edge of the network, compared to when you are supposed to deliver these resources from the origin servers or cloud servers. And these servers are very far from the devices they communicate with. But with CDN, you can improve the experience of your customer by delivering a local copy of the content from a nearby cache edge. Then throughput is dramatically increased, given that the web assets are delivered from cache. Since the web assets are delivered from cache, the throughput is increased dramatically. Okay, so a primary purpose of a CDN edge server is to store content as close as possible to a requesting client machine, thereby reducing latency and also improving page load times. So CDN basically stores your web resources, your web content, as close as possible to a requesting client machine. So this helps them deliver these resources quickly to the client machine when it is requested for. And this reduces latency and also improves page load times. Next, we have the domain name system caching, DNS. Every domain request made on the internet essentially queries the DNS cache servers in order to resolve the IP address associated with the domain name. So DNS cache refers to the temporary storage of information about previous DNS lookups on a machine OS or web browser. So DNS caching allows any DNS server or clients to locally store the DNS records and reuse them in future, eliminating the need for new DNS queries. And DNS implements a time to live, TTL, on every DNS record. Time to live simply specifies the number of seconds the record can be cached by a DNS client server. And so we also have session management. HTTP sessions contain the user data exchange between your site's users and your web applications. A session cache allows a server to store session information from multiple clients. So this session cache allows you to store information from your customers, and this can help you deliver great user. This critical to providing great user experience on your website is managing your HTTP sessions effectively by remembering your user preferences and providing rich user content. For example, you go to a website, you search for something that is something that, I don't know, you search for anything. Then next time, when you go on the web, you go out to another place on the web, you would see that they are kind of crafting content that is related to what you have searched for before. This is session management, because as you perform some requests on the web, some of your information are stored, and this can help provide great user experience for customers. And utilizing a centralized session management data store is the ideal solution for a number of reasons, including providing consistent user experience across all web servers, better session durability, and higher availability when session data is replicated across cache servers. Then we have web caching. When delivering web content to your viewers, much of the latency involved with retrieving web assets, such as images, HTML documents, videos, and the likes, can be greatly reduced by caching those artifacts and eliminating disk reads and server loads. So web caching techniques can be employed both on the server and on the client side. So lastly, we have the general caching. Accessing data from memory is orders of magnitude faster than accessing data from disks or SSD. So leveraging data in cache has a lot of advantages. In addition to speed, application benefits from high throughput at a cost-effective price point. In conclusion, caching is the process of storing copies of files in a cache or temporary storage location so that they can be accessed more quickly. Technically, a cache is any temporary storage location for copies of files or data, but the term is often used in reference to internet technologies. Web browsers cache HTML files, JavaScript, images, videos in order to load websites more quickly, while DNS servers cache DNS records for faster lookups, and CDN servers cache content to reduce latency. Thank you for listening, and if you have any questions, you can go ahead and ask. Thank you.
Thank you for the wonderful presentation.
Yeah. So thank you.
Any question?
Patrick, you can stop the live stream.